Okay, welcome back to my class. In this video, we want to talk about real analysis, and then we have a question on the board that said that prove that if epsilon is positive, that is greater than 0, and we have a and x, which is an element of a real number, then that the absolute value of a minus x is less than epsilon if and only if x minus epsilon is less than a, which is less than x plus epsilon. Now, this is a question gotten from Professor Chidume's textbook. Okay, this is exercise 1, question number 1. I have decided to solve everything in that exercise so that it will help students that are offering this analysis to understand it better, because this is one of the most difficult courses we encountered during our time in the university as an undergraduate. So now to solve this, first of all, let's start with the definition of absolute value. Let us know what the absolute value looks like before we can solve it. Now, for you to get absolute value, there are conditions for absolute value. The absolute value of x is equal to x is equal to itself if and only if x is greater than or equal to 0. So, and then it is negative of itself if and only if x is less than 0. So what do we mean by this? This means that absolute value must be positive. Let me give you an example. An example to this is that the absolute value of 5, if you look at 5 is greater than 0. So the answer is going to be 5. So it's going to be 5 itself. So the absolute value of a positive number is itself. And the absolute value of 0 is equally itself again, 0. So whenever it is greater than, whenever it is positive or 0, the answer should be itself. But if it is negative, that is if it is less than 0, that is if it is negative, the answer is going to be negative of itself, which is going to be what? 5. So that is why we conclude that absolute value must be positive. Okay, so let us use this concept of absolute value now to solve this. Now, to solve this, now this is a question of if and only if. And if and only if condition shows that, first of all, you have to, if you assume that this is true, then this must be true. And then in reverse, if this is true again, this is true. So you are going to check the two of them. We must start from here. We are going to assume that this is true, and then we show that if this is true, then this is true. Then in reverse again, we will now show that if this is true, this is true. So let us start with this one now. Now, we're going to have two cases here, and the first case is when everything inside this absolute value is going to be positive. And then the next case is now when everything inside this absolute value is going to be negative. So now, if you look at this now, the only condition that will make everything here to be positive is that if a is greater than x. If a is greater than x, then everything here is going to be positive. So that is case 1. So our case one is, we say that a is greater than x, because that is the only thing that will make it positive here. So if a is greater than x, you will now see that absolute value of a minus x. Remember that if a is greater than here is now positive. So the absolute value of a positive number is the same thing. Okay, and then from here we have that the absolute value of this, we have already assumed that the absolute value of this is, I'm talking about the first one also, you can write it. The first one is that we assume that the absolute value of a minus x is less than what? Epsilon. That is our assumption. So if we assume this, then we want to show that what? X minus epsilon must be less than a, which is less than x plus epsilon. Okay, so now, so obviously that the absolute value of this is less than epsilon. That is our assumption. So this, which is equal to this, must be less than what? Epsilon. You get that? So from this point now, you will see that, let me show you something. If we have this is our 0 here, this is the middle 0, and then we have a number here, a minus x, which we say that it is less than this. So our e must be here. So if you look at these three things, you will see that 0 is less than this one, and this one is less than this. So this one could be written as, so this one implies, this two now implies that what? That 0 is less than a minus x, which is less than what? Epsilon. Okay, so now from here, remember that we say that epsilon is greater than 0. If we multiply both sides by negative, I'm going to have that negative epsilon, you will not change the sign, is less than what? Is less than 0. Are you with me? Now, Let me draw it again for you to understand. I have that here is 0, here is my a minus x, and then here is my e. So if minus e is less than 0, therefore minus e is going to be this side. So if you combine everything here, you are going to be having that minus epsilon is less than 0, which is less than what? A minus x, which is equal less than what? Epsilon. So if I remove the 0 here, I'm going to be having that what? Minus epsilon is less than a minus x, which is less than what? Epsilon. Now let us add x to all the sides. If I add x, I'm going to have that x minus e, because I'm adding x here, or let me write it the way you understand first. I'll have that minus epsilon plus x is less than a minus x plus x, which is less than what? Epsilon plus x. So if you have this, you rewrite this to be what? X minus epsilon is less than this, and this is gone. A, which is less than what? X plus what? Epsilon. That is exactly what we have here. Okay? So the first condition, we have satisfied the first case. Now let's talk about the second case. So permit me to clean here because my board is too small. So let's consider the second case. Okay? Now for case 2, for case 2 now, we need here now to be negative. So the only thing that will make here to be negative is that if a is less than x. So the case 2 is that what? A is less than x. And if a is less than x, you will notice that the absolute value of what is inside here is going to be equal to negative what is inside here. Like we said here, that if x is now a negative number, then the absolute value of it is going to be negative of itself, like we did here, negative of itself. Okay, and then from here we know that the absolute value of this is less than epsilon, so we say that this is less than what? Epsilon. Okay, now if you multiply both sides by negative, I'm going to have that what? That if I multiply this by negative, this negative will be out, so I'm going to have that what? That a minus x must be now greater than negative epsilon, because the sign will change. So if you write this thing, you're going to have that negative epsilon is less than a minus x. So if I multiply both sides by negative, I'm going to have that what? That a negative epsilon is less than what? A minus x. Okay? So now, if we have this now, and then we know that from here again, that epsilon is greater than 0. Okay? That epsilon is what? Is greater than 0, which means that 0 is less than epsilon. Is it not true? So if 0 is less than epsilon, let us draw this one again. If we draw this one again, I'm going to have that this is my 0. If I have that here is 0, then I'm going to have that. Remember that this place is negative, so it's going to be somewhere here, a minus x. And this one is less than itself, so this is going to be this side. Okay, so if this is going to be this side, I'm going to be seeing that what? That epsilon, that 0 is less than epsilon, so epsilon itself is going to be this side. So if I combine everything here, I'm going to be having that negative epsilon is less than a minus x, which is less than 0, which is equally less than what? Epsilon. So if I remove this now, I'm going to be having that negative epsilon is less than a minus x, which is less than what? Epsilon. So you see that it is proved that if we assume that this, the case 2 is true, because if you assume that this, that the absolute value of this is less than epsilon, then if and only if this. So if we assume that this is true, then this is true. If you look at it, so what do we do here is to add x to both sides, to all the sides. So if I add x everywhere, I'm going to be having that x minus epsilon is less than a, which is less than what? X plus epsilon. So we approved the first one. So the next one is now that we are going to assume that this is true. Then we have this. Okay, so that is the next one. So permit me to clean here. So my case 1 and 2 is already proved. So let me go to the sufficient side, so which is this way. I've gone the other way. So for this way, we are going to assume that x minus epsilon is less than a, which is less than what? X plus epsilon is true. That assuming this is true, then we have to show that absolute value of a minus x is less than epsilon. Okay, so that is what we want to prove. So in the same way, the same thing again, it has case 1 and 2. So case 1 and 2 is that the case 1 is that a is less than x. Okay, so 1 minute. Okay, so in case 1, sorry, this is case 1, and I tell that in case 1 that a it should be greater than, sorry, a should be greater than x. And if a is greater than x, then we're going to have that the absolute value of a minus x, if a is greater than x, here is positive. So, and if here is positive, it means that it is equal to itself, which is a minus x. Okay, and then if you look at this, you see that, okay, from here we can write here to be, watch me, we can write here to be subtract x from everywhere to have negative epsilon is less than a minus x, which is less than epsilon. So subtract x from both sides. So if you look at this, you see that this is strictly less than this. So we say that it is less than epsilon. So if you look at this, you see that if this is equal to this, so it means that what? It implies that absolute value of a minus x is less than what? Epsilon. So from here now, we've gotten that from here, then we have this. So that is for case 1. Now for case 2, we have that a is less than what? Epsilon. So if a is less than epsilon, we know that the absolute value of a is less than x, not epsilon. Absolute value of a minus x here is now negative, so it's going to be negative of itself. So negative of itself, and negative of itself here, this is going to be that that we still know that negative of itself. Okay, and this is going to be less than epsilon. Let me tell you why it's going to be less than epsilon. It's going to be less than epsilon because from these two, look at these two, let's have that negative epsilon is less than a minus x. If I multiply both sides by negative, I'm going to have that what? Negative of a minus x must be less than what? Epsilon. So that is how I knew that this is going to be less than epsilon. So if this is going to be less than epsilon, so it is going to mean that that the absolute value of a minus x is still less than what? Epsilon, which is just this. So, and that is that for that. So the case 3, which is when this is equal to this, is a trivial condition. So with this, we will now say that what? That the proof is correct, or you can just write for them proved, and that is just that. So thank you very much for watching this particular video. So in the next video, I'm going to do the question number 2 of that exercise. May the peace of the Lord be with you. Bye bye.